Hello and welcome to this calculus video. Today we will be talking about rules for computing derivatives.
Math 112.
We have defined the derivative to be the limit of the slope of secant lines, but as you may have found, directly computing this limit can be a lot of work, even for simple functions. Today we're going to develop some rules that allow us to differentiate functions more quickly. The best way to get familiar with these rules is to practice them until it comes naturally. We start with the simplest kind of function, a constant. We can compute the limit directly and show that the derivative of a constant function is 0. Let's step up in complexity to f of x equals x to the n. These functions are powers of x, and we call the rule for differentiating them the power rule. It works by multiplying x by the power and reducing the power by 1. So then x to the 3 prime is 3x squared, and x to the 6 prime is 6x to the 5. Technically, at this point we only have the tools to prove this rule for positive integers, but it is true for all powers, as we will see when we learn about logarithmic differentiation. Now let's consider an exponential function, f of x equals a to the x. Note that this is a power of x, and so we can't use the power rule to differentiate it. To use the power rule, the power must be constant. With an exponential, the power varies and the base is fixed. If we try to compute the derivative of a to the x from the definition, we can use the laws of exponents and some algebra to simplify our computation. The a to the x does not depend on h, and so it can be pulled out of the limit. The limit that remains is exactly the derivative of a to the x at x equals 0. What this computation shows is that if an exponential function is differentiable at 0, then it is differentiable everywhere, and that derivative is proportional to the original function. If we explore this numerically, we find evidence that the limit does exist, and that somewhere between a equals 2 and a equals 3, there is a value so that the limit is 1. We call this quantity e, i.e., e is a number so that e to the x prime evaluated at x equals 0 is 1. This means that e to the x prime equals e to the x. Values of a other than e will have to wait for a future video. Now we move on to some rules for differentiating complex functions that are built out of simpler functions. The following rules all assume that the derivatives of the simpler function exist. We start with a scalar multiple. The derivative of cf of x is cf prime of x. For instance, the derivative of 3x to the 4 is 3 times the derivative of x to the 4, which is 12x cubed. We also want to be able to differentiate the sum, difference, product, and quotient of different functions. The first two of these are easy. The derivative of the sum is the sum of the derivatives, and the derivative of the difference is the difference of the derivatives. These are called the sum and difference rules respectively. As an example, the derivative of x plus e to the x is the derivative of x plus the derivative of e to the x, which is 1 plus e to the x. Products and quotients are more complicated. Unfortunately for students everywhere, the derivative of a product is not the product of the derivatives. To differentiate f of x times g of x, you differentiate f of x and multiply it by g, and add to that the derivative of g of x multiplied by f of x. The derivative of a quotient is even harder. The derivative of f over g is g times the derivative of f minus f times the derivative of g, all divided by g squared. I have heard many students remember this by saying low d high minus high d low over low squared, and this seems to work for them. Let's compute some examples. The derivative of x squared e to the x is the derivative of x squared times e to the x plus x squared times the derivative of e to the x, which is 2x e to the x plus x squared e to the x. Also, the derivative of e to the x divided by x is x times the derivative of e to the x minus e to the x times the derivative of x all over x squared. This simplifies down to x e to the x squared minus e to the x all divided by x squared. That's all for today, folks. In this video we found the derivatives of constant functions and powers of x, and we defined e to be the number so that e to the x prime is e to the x. We also stated the rules for differentiating the constant multiple of a function, as well as the sum, difference, product, and quotient of two functions.
Math 112.